Can everybody see without lighting, or do I need to turn these lights off?
Right there.
Turn these lights off right here?
Yeah, because they're reflecting on the
Okay.
screen.
Sorry. Not that one. Having fun? There you go. Is that better?
Yeah.
Everybody have that down? Yeah? Okay. So, when we're talking about spark plugs, this is a brand new one in a package. So when you guys see them, this is what you'll see out in the field. It's designed this way because if you happen to drop it on the side of the electrode is, it will actually act as a cushion and you're least likely to break it. Because once these things are open, you drop them on the floor, you might as well drop them in the trash because 95% chance you broke something inside. So when you see a brand new spark plug, it'll look just like this. Okay? And we're going to go through what these numbers have meaning. Each one of these have a meaning. So we're going to go through that. There's a lot more to spark plugs than I ever thought possible. Okay, so construction.
What was that number?
They're going to all be different. This is just a brand new one, but you'll see different numbers, so it doesn't really matter. This is a pretty popular one you'll see, but they'll all be different. And we're probably going to break down this particular one. So you're going to know what the R means, you're going to know what the H means, the M, and so forth.
So that's an air cushion?
It's the way it's packaged. It's packaged so there's air in there,
Okay.
so kind of supports it. Plastic's pretty thick. I've got quite a few of them open. Everybody have that wanted it? We're gonna go through it, like I said, as we go on to the sides. So the construction. Oops, sorry. So spark plug is composed of three main sections: the metal shell, which is the outside, the ceramic electrical insulator, and the core seal electrodes. So we're going to go through each one of those sections. So after we're done, you'll know exactly what each one is. Everybody got that down? Yeah, okay. So the metal shell is a machine and plated steel. It's threaded on both ends. So there's the radio shielding end, which is the side that the harness goes in, and then the other side that's attached to the cylinder head. The electrodes are also made, so the little electrodes on the top of the spark plug that screw into the cylinder could be made of steel, could be made of platinum or iridium. And we're going to go through each one of those. And these shells are usually plated or painted for because there's also moisture in the air and stuff like that, so we don't want them to rust, and that's why they usually plate the steel. Or some cases it'll be heavily painted. Does everybody have that? Yeah? Okay. So the ceramic electrical insulator. So when you look inside, let me go grab a spark plug. You guys are writing that down. So the ceramic part we're talking about is on the inside of here where the harness goes into. So when you guys take a look at your spark plugs, when you guys do your cleaning and everything, you'll see the ceramic inside. And basically that's just the protection between the metal shell and the actual electrode inside. It's preventing it from grounding out onto the shell and keeping it in the center. Everybody got that? Alright, the core section, which is the center part, includes the terminal contact, the contact spring, the resistor, the glass or copper seal, the copper sleeve, the copper or silver core steel or iridium center electrode. So this is talking about what's inside of here. There's a resistor in here. There's actually, if you look straight down into your guys' spark plug when you get one, or if you guys want to take one out, I actually have a slide that shows you what's inside. But when you look straight down in there, it looks like there's a flat-headed screw or a screw in there. You just stick a flat-headed screwdriver in there, you back it out. There will be a spring and a resistor in there. Most of them have that. Some spark plugs don't have resistors, but most of them nowadays do. We do not take that actually apart on the spark plug out in the field, but we did it just for educational purposes, and that's why I have a slide in there for you guys.
Maybe you're talking over.
Oh, I'm sorry. We're gonna go through all this. So you're just writing it down, but I'm just gonna reiterate it as we go. Sorry, it's kind of boring just standing here while you're typing. everybody get that down? Okay. So if you missed it since you were writing down the slide, there's a resistor in here with a spring. If you guys look directly inside your guys' spark plug, when you get one, I have a picture of it. There's actually a screw in there, flat-headed screwdriver. If you back that out, you'll see a spring and a resistor in there. Like I said, we don't take these apart in the field, but I have a slide that shows you what's inside because just for educational purposes. And I will go through why we need a resistor in there. And like I said, some of them don't have a resistor, and we'll talk about that as well. Okay? Good to go?
Thank you.
Okay. I'll wait till you write it down.
You can eat your chocolate while you're
Lonnie's already given me like 3 dozen oatmeal cookies in the last couple of days. Seems like.
Can you kind of explain the resistor thing here about new, used, and explain it?
I will. Does everybody have that pretty much written down? Okay, I'm not going to change the slide. I'm just going to start talking. So, this new, used, and discard, this is actually the resistance of the spark plug. So, over time, these things start to get a higher resistance in them because they're worked and everything. So what I'll explain to you, I'll explain the resistor first, and then I'll go into this. So the resistor basically acts like a capacitor that you guys have in your magneto. Your magneto, the capacitor does what for the magneto?
protects the contact.
Protects the contact points, right? So the resistor is doing the same thing inside a spark plug. It's protecting that gap in there. Because if you have 20,000 volts going through, but you also have all that current traveling down that harness as well. So what the resistor does is it slows down that current. So it won't burn the gap as much. It acts just like the capacitor does. So if you're constantly having so much current in there, it could also happen, it could give you back and forth. So when you have current going through and it's jumping that gap, right? Okay, you know I was talking about earlier in the semester, we were talking about if everybody ran to the door, some of you guys would get out, but some of you wouldn't, and it wouldn't be able to make that jump, how people would fall back if everybody crammed to the door first. So it'd be like a tunnel, and some people would fall back. Well, that's the same thing with this current. Not all the current will have enough power, or all the voltage will have enough current to jump that gap the first time. So what it wants to do is it wants to go back to the lead, bounce against the coil, wherever, come back, and make another spark. What this resistor does is it helps it to bleed off that extra current so you don't have that problem. So that's what the resistor does. Over time, the resistor wears, and its resistance gets too high, and if you have too much resistance in there, you can't make a spark. So over time, spark plugs' resistance will get too high, and it won't work.
So that's what I was confused about. Was I didn't know that. I would think that resistors when they're used would be the opposite.
It would be the opposite. Yes, I agree with you. That's how I look at it too. But it actually builds the resistance in there. So as that wears down, it makes more resistance in that area where it won't jump the gap.
It's like it gets clogged too.
Yeah. So does everybody kind of understand that? So you got a lot of voltage going through that harness. So we're talking about from the magneto to the spark plug. So you have your harness that's traveling down, right? You got 20,000 volts going through there, right? You also have a lot of current. Do we agree? So there's current going through there. So what the resistor does is it holds that current so it doesn't constantly be jumping the air gap. Because if you have that, it will start to wear the gap too much, just like in the magneto with the points. That's, yes.
I thought we traded voltage for current. So that
We did,
okay.
but there's still current going through there. So you're still harnessing current in that harness. And to move that voltage, you're still going to need some current. And we don't need that much current to jump that little bit of gap. So that's why the resistor does that. Does everybody understand that? It's important to understand what this resistor does. Because if you don't have this resistor, which some airplanes don't have, their spark plugs don't have resistor, they don't call out for one, they're older aircraft. So you actually have points that break down. Because this current might, if you don't have the resistor, it goes back through that harness and it'll actually wear out the magneto. So it'll go back through the distributor, it'll go back through that carbon brush. You guys know that little carbon brush in there that you guys have? It'll actually wear on the coil where you have your copper tab. And that happens a lot in airplanes that have spark plugs that don't have resistors because of that current that's bringing it back. Does everybody kind of understand that? Does that make a little bit more sense? I know it's weird. You would think that the resistance would go down, but it doesn't. And it's weird, but as that part breaks down, it holds more of the current in where it won't actually travel because it's going out somewhere.
So it's like driving on that's 15 when it's clogged up.
Kind of, yeah. All of it's just hanging out there because it can't actually continue on to out to the electrode.
Did anybody see that car on fire? I was driving to school and there's a car right on fire on the highway.
15?
Yeah, on 15.
I was coming the other way probably, so I didn't see it.
I mean, this thing was ablaze.
Okay, and also you guys, I want you guys to remember these numbers because you're going to do your project in the lab, and you're going to test each of your spark plugs to see if they hold a resistance or not and what the resistance is. And I'll show you what they look like on the meter. Actually, I have pictures of what I used one, a new one, and which one you want to throw away. Okay, so kind of keep those numbers mentally in your mind. Okay, so, wait, sorry, I'll wait till you write down. I'm working on it. I have some people just take pictures. Everybody have that written down? Not almost? So, at 5,000 ohms of resistance, the plug will probably still fire, but it won't be a great spark. So in that, we could have hard starting, we could have misfire, poor combustion, and poor combustion leads to higher exhaust pollutants. And that's because we don't burn all of the fuel in there. So, where's it going to go? Does everybody see that? It's going to go out the exhaust, right? So when you guys are dealing with ignition system, most likely if you have a problem, it's going to be spark plugs. I would say about 90% of the time, that would be where your problem is. Something's wrong with your spark plug or your igniter if we're talking about a turbine. I'm not saying that's all the time, but that would be the first place to look. One, because it's the easiest. Most of the time you can access them. It's the cheapest and you can look at it, but most of the time it's at the spark plug. And the reason for that is they're exposed to the elements. They're exposed to crap. I mean, they're heating up, they're cooling down. They're constantly coming in and out of the aircraft during annuals. People are taking them out, putting them back in. They're cleaning them. Somebody may drop one, just mishandling of them. Somebody might over-torque the harness, crack the insulator, and so forth. So they go through the most tough times, and that's why they break down. Okay? Everybody understand that? See that? Okay. Try it here.
Is that last sentence right? Because it's capacitive after fire.
Capacitant reactance causes capacitant after firing, yeah. And I'll explain what capacitive reactance is. That is correct. Because that's what the resistor knocks down. So we have that kind of written down. So, remember what I said? It acts just like the capacitor does. So it basically helps with bounce back. So when you have current going through, the voltage going through, you're still going to have voltage wanting to jump that gap, but the current isn't there enough, and so it'll come back and it'll bounce back and it'll want to make another spark before it is time to make one. And that's what they call capacitive reactance. And what the resistor does is it helps reduces that. So this is after firing, so it's going to fire again before you want it to. So you'll have a double spark, and you don't want that. So it'll spark, and it'll spark again before it's time to actually spark it. So if you set the spark plug off on the wrong stroke, what could happen?
Backfire.
It could backfire, right? We don't want that, especially if all the other cylinders are going the right way. It's going to cause major problems, and that's what that kind of avoids. So who asked me if that sentence was correct? Yeah. So that's what that means. Does that kind of make sense?
Yeah.
Okay. So does everybody understand that?
Can you explain it?
No. I'm still trying to wrap my head around it. I understand what it is, it's just I've never heard that term before.
Capacitive reactance.
Didn't
Just
we
say it one more
calculate that
time.
in Power plant electrical or airframe electrical capacitive reactance?
I don't know
Oh.
who your airframe electrical teacher was or your power plant electrical.
Now I know what it is. How cool is that?
Have you taken power plant electrical, airframe electrical yet?
I've got 2 semesters left, probably.
Probably one of those? Okay. So you kind of understand what that's doing? Do you guys kind of understand what the resistor is doing? It's very important to understand what it's doing because it's going to help extend the life of all the other parts in the magneto and the harness because you're giving that current somewhere to go. Anybody have any other questions about that? How many of you guys knew there was a resistor in the spark plug?
But I are red. Or my computer read to me.
Your computer read to you. Alright, let's continue on then. Okay, so just like I said, it is a voltage bounce back. Results in extra wear to the spark plug electrodes. Wear is worse on spark plugs with longer ignition leads. So that's basically what I was talking about, was the bounce back.
Is that the official term? No.
It's a lot better than capacitive reactance. I understand bounce back. I don't know if there's an official word for it or not.
So if the shielding is non-conductive, which hopefully it is, you know, 'cause it's silicone or whatever else you're using, how does it still build up a capacitive charge?
So, you got voltage and current going. You're talking about the harness, right?
Yeah.
The actual thing. Okay. There's a field going through that. As the longer that harness is, you have a field, electrical field building in
Right.
there. Okay. So what exactly is your question?
Well, isn't the shielding to protect the radio equipment?
Yes.
Well, yeah, but it'll still build up the field, because whenever you pass a current through a coil, through a wire, it builds up a field. I don't know, I guess I wasn't thinking about it that much.
Because. So did it answer your own question, or?
I guess so. I was thinking that somehow the non-conductive shielding was acting like an electrolytic capacitor or something, and building up, you know. But there's no electrolyte or anything. It's not building up capacitance that way. It's building up capacitance by the nature of it building a magnetic field.
Yeah.
Yeah. I just thought it was doing something like an electrolytic capacitor.
No.
It's just building up magnetic field, which then, yeah, that makes more sense.
And does everybody understand why the longer the ignition leads, the worse the wear is on there? So the voltage is going to be the same throughout the whole harness, right? But you're going to have more current hanging out in there because it's a longer wire. So it's going to wear down that harness quicker. And that's why they try to make the harnesses shorter on higher voltage aircrafts.
Because the temperature will be higher from the current hanging out.
Yes. But and when you have more current hanging out, there's more wear that can happen because of heat, all sorts of other things. But that's exactly what happens with the coil. The coil. So if you didn't have that resistor, it's not only the harness that you're thinking about. It's going to go back into the magneto. It's going to travel backward. It's going to bounce all the way back through the magneto. It's going to wear out the distributor. It's going to wear out the carbon brush. It's going to wear out the coil because it's heated up because there's so much current in there. It's going to heat up that coil and it's actually going to burn that coil up. Everybody with me? Okay. All right. So, what?
He said if you could afford a plane, you could afford to buy more spark plugs. I said, I wish that's true.
I can't even afford some of the spark plugs that go into aircraft.
No.
So, we've actually taken a picture of what the meter is going to look like when you have a brand new one. So this is a brand new spark plug. If you guys notice, it's in kilo ohms. So, what is this reading right here? 865 ohms, right? Is that in a good spark plug?
Yeah.
Okay. So that's what you're gonna see on the roughly around that on the meter on a brand new one. Okay. So if you don't have any resistor in there, you see how this is just rated in ohms. That's just a half an ohm. So I know that this one doesn't have a resistor in it just by the measurement on the meters telling me. And this is a brand new spark plug. This is the non-resistant one.
Well, and you said that's for older planes?
Most of them you'll see in older planes. It's whatever the type certificate data sheet calls out for that aircraft. So I'm actually going to have you guys research. We're going to do kind of like a research thing, and you're actually going to go look at these and see what is rated for that aircraft. So if your airplane is rated for a spark plug that has no resistor, it's rated for an airplane that has non-resistor in it.
So that'd be like in like a C65 or something like that.
I don't know. Is it in a C65?
When it, other than the resistors, when it comes to design, are most spark plugs pretty much universal?
No, actually, we're going to go through a thing called REACH as well, which is for higher cylinders. So cylinders that go to higher altitudes that run at higher speeds, they actually have a longer reach spark plug, and the reason for that is because it disperses the heat a lot easier. We're gonna go through that too. So you can't just swap spark plugs for this aircraft for that one. They're rated for the actual aircraft they're on, or engine they're on.
Wouldn't the data sheet be on the engine, not on the aircraft?
Yes. Sorry, when I say aircraft, I did mean the engine. Just like these are engines, and we're gonna go through these, and we're gonna go through what the spark plugs mean and everything else, because they're all rated differently. They're rated for temperature and reach, which we're gonna talk about here pretty soon. So everybody sees what a non-resistor type looks like. So when you guys are doing your project, you're gonna be measuring these. And Lonnie last year made these cool little guys that go in here, so you don't actually have to stick the prong in here all the way, and you can just measure it right there to see what the ohms are. Because sticking the lead in there, you could end up touching the side, and it's a big mess. So he actually designed those so you can actually touch the outside of them, and I'll show you. It's a little Hiziachi thing. But this is what you'll see if you have a non-resistor. Okay. So what is this one reading? So we're in kilo ohms again. What is that? What is that reading?
13,000.
31,000, right?
No.
No.
313,000.
Yeah.
Okay. So is that one a?
It's a big one.
That's a big one.
That's a discard.
Yeah, I would probably chuck that.
You said over 5,000, right?
Over 5,000, but you might, like I said, you will see if you're at 5,000 or a little bit over 5,000, you will see it. Most likely, you'll probably see a spark, but it's not going to be a great spark. And we have a tester here, and you'll be able to see it when you put.
So when it gets to like, say, past 5,000 or whatever, to get to 313, is this guy just completely neglecting it, or is that like does it quickly build up resistance in a short amount of time?
It drops pretty fast. After
Drops
it's
pretty
already
fast.
past that 5,000, it drops pretty fast.
Okay.
So it's not uncommon to see these.
And that's the center electrode?
Yes, you're measuring the center electrode. Okay, well, I have a picture showing you where that resistor is, but through here is the center electrode, and then the resistor's on this side, which pushes up against the electrode. So the spring that's holding it in there pushes up against the electrode. So here's another one. What is this one at?
121,000.
So you can see how pretty common these are. We just pull a bunch of random ones that we had in the shop, and some of these happen to be that high. The red tape is to show that they're no good. Okay, so the meter is a great way to do this. They also have this doohickey. They sound like doohickey. This tester that Tempest makes. That if you're doing a lot of these, all you gotta do is put this in there, tap the top of it. When it's green, it means the resistance is good. When it's red, the resistance is bad. Most people don't use these because your meter does the same thing. Most of us have meters in our boxes. We don't have one of these. If you're so inclined to buy one, I hear they're like $150 or whatever. If you're doing tons of them, you might see it in a shop somewhere. Even the shop I worked in didn't have one of these. We use the meter. And we use the tester to see if it fires. Oh, it fires, it's great.
Is it cheaper to replace it or cheaper to change the resistor out?
You can't change the resistor out.
Okay.
So technically, you're not supposed to take these apart. Like I said, we're not supposed to, but we broke one loose just to see what was inside. But yeah, you're just gonna replace it. There you see that? So like I said, if you guys feel inclined to buy one of these testers, they're great, but they do the same thing your meter would do. Okay? Alright, let's see how far this goes. Okay. Internal resistor. Wait till you write that down. Okay, so basically this is just reiterating what I already talked about. We discussed why it extends the life of these parts in the magneto. It helps with that bounce back, with having current going back through with that voltage, burning up parts and so forth. Is everybody with me so far? Okay, everybody get that written down? Yeah, okay. So, here's a breakdown of what you'll see inside the spark plug. So here's the screw that you'll see inside when you look straight down into the ceramic part of the spark plug, and you'll see a resistor and a spring. The spring is what puts the pressure, pushes it against that center electrode. That's pretty much all you see in there.
Is that resistor carbon?
Looks just like the one you guys had, like your little carbon brush that you see in your magneto.
I mean, if it's so simple, why can't we just replace that one one-time piece?
If it's so simple.
Probably worn out anyway.
Yeah, because you're probably worn out with the gap and so forth. And that spring is rated at a certain pressure to push against the electrode. I don't know if it's how it's torqued in there, but the spring plays a key factor of how hard it's pushing up against there. Yes, it is simple, and I probably could put one back together and it worked just fine. But like Brian said, there's probably more wrong with it if the resistors got problems. Did everybody see that in the back? You guys are so alive today. So, here's a cutout, a cutaway of the inside of a spark plug. So, here's your resistor, here's the spring, here's the ceramic.
Is that a ceramic hole cap kind of deal? Well,
If you look straight inside
emptiness.
there, you'll see the ceramic.
okay.
So it looks just like that. So if you guys want to take a picture of that, you can. There's also a seal in here, a glass seal, that you can't see unless you have a cutout. We don't actually have a cutout, and you can't take that part out even when you take the screw out. But what it does is it helps prevent leakage of fuel coming through here and going out that way. It's just a seal.
Fiber or is that fiber?
Fired.
What do you mean prevents seizing? I mean, just a little confused about that.
So seizing is where you can't back it out. So where it's seized in there, it's locked in there. So that plating helps prevent it from seizing inside the harness.
Gotcha.
Okay. Does everybody want a picture of that? Got a picture of it? I don't know if there's a cutout in your guys' book. I didn't see one, but. And here's another one just by Tempest. Just so you guys can get a good look at it. We were hoping to get a cutaway, actually get somebody to cut one away so you can actually see inside and see what's in there. And I don't see the resistor, but it's somewhere in here. I don't know why it's not called out for there. So is everybody with me so far on this? Spark plugs are pretty simple, right? Okay, the electrode design. So they all have different kinds of designs. This one is the basic one I pretty much see everywhere. This is the massive 2 electrode. So this is the steel one, 2 steel sides, and you notice, and when it says it's massive, it's because those sides are so thick. So when you guys see the platinum and the iridium, they're so thin compared to this one. And one of the designations on those numbers you saw on the new spark plug actually calls out for which one you're gonna have.
Which the 2 things on the side are electrodes?
Yeah. So the massive 2 electrodes. So you have a set electrode and then you have the 2 sides. And that's what that is referencing to. Because you decided there's pictures, you don't have to write anything.
No, you gotta try it out.
I wrote something.
Have to draw it out?
Yes, sir.
You're like, no.
I can draw a smiley face.
Are you guys ready for the next one?
Still write those down.
Oh, well, we can wait another few minutes. It's okay. I got plenty of time in this class to do that. Okay, so obviously this one says a mass of 3 electrodes. So you count 3, right? And that's what it's designating to.
James, you got that? Count 3.
You got that copy down?
down for me. You got that, Judy?
You can check his YouTube channel later.
Yeah.
check it.
So if you need more time, James, I'll give you my subscriber.
No, I'm good. I don't want to watch your YouTube video.
Does everybody have that down that wanted it, a picture of it? Yeah? Okay. So here's another one. Here's a mass of 4. Most of the time you'll see a 2, I think, in pretty much smaller engines. And all of these are just for redundancy. So the 4 is just for redundancy. You probably see it in a bigger engine.
I've seen those 4 electric ones on really old engines too, like in museums type thing.
Yeah. It's just whatever the manufacturer calls out for. I've seen them in some aircrafts, but most of the time I see the 2. And like I said, they're for redundancy.
If so if for whatever reason one side fails, it's still
It's still going to spark. And I've been told, for some reason, these will never all spark at the same time. So technically, they're all supposed to be jumping the gap at the same time. But theoretically, this gap could be just a hair bigger than the one next to it, so it will jump. So if this one was completely crushed and we didn't have any gap between them, theoretically, the other 3 would still be working. And it's just for redundancy why they have those.
No.
No?
No, if one gets pushed over to the center, it's grounded.
Oh, that is true. If it's completely closed, I'm sorry. Yes, if it's completely closed, it's grounded. But if
What
one's
it does is it prolongs the life of a gap. So when one wears, the gap opens up a little bit, it jumps to another one that still has the correct gap. And then when that one wears, it goes to another one.
but they all jump every time.
so maybe
No, they don't.
so maybe
Not
that's
all the
why
time.
You only get one spark.
Well, then you only get one spark. But what I'm saying is, this one will jump, but this one will jump. This one will jump. This one won't continuously only jump. That's
No,
what
it'll move around, but
Yeah,
it
but-
won't. All 4 won't spark.
No, they
every
won't spark
occasion.
at the same time.
Right.
But what I'm saying is, you're saying when it wears this one, it will go to the next one.
Right.
No, even if this one is, it'll still jump. It's even if this one isn't completely worn, it'll still go to the next one. They'll still all, but they won't all spark at the same time.
Right.
So even if this one, even if this gap is not completely out of range, it'll still fire the next one. It'll still
Right.
jump the other one.
Yeah, that's why it maintains the gap, because when one wears, it just moves to the next one. Naturally.
I get what
You
you're.
guys are saying the same exact thing.
We are saying
I do understand.
Okay.
Success.
He understands the exact same thing. Okay.
is that maybe
Well, because I was incorporating is that it will keep firing this one until this one comes out of range, and then it'll fire this one.
Yeah,
And
he's saying the same thing. He's saying he's saying it's a little shorter.
Oh, okay. Yes.
how common is it for the electrodes to full contact where they ground themselves?
Run
Like
that by
if
me
you were
again?
saying like
How would that happen?
how huh?
Foreign object.
Or not, I mean more like
Carbon,
how common
Yeah.
is it one of
Piece
the more
carbon
common
breaks off the
factors?
piston.
of
Yeah, it's a
what-
huge factor. You get carbon in there all the time. You get all sorts of stuff in there.
As in that's why they would have well if it's grounded then the whole thing's screwed, right?
Yeah. So if you have a piece of carbon in here that's touching both sides, yeah, it's not gonna work.
Ground it out. Misfire.
Okay.
Get that?
Yeah, I'm just wondering maybe that's why the two electrodes is more common because there's less chance of if you got 4 of them there's more chance of
One of them getting
grounding.
grounding out.
and then instead of 2 I don't know whatever not that matters. Let's go to the next slide.
Well, it does matter. It does
We
matter.
spent a lot of time on But
Well, there is a lot of time on spark plugs because, like I said, 90% of your failure is going to be at the spark plug. So, all right. This is what you see in an automotive single-sided electrode. Do you agree?
Yeah.
I'm looking at you.
Yeah.
My car guy over here, I'm looking at you. So,
Although I think Toyota
I don't
has
know about
a
that.
4-prong or a 4-electrode.
okay, but this is the single one, right?
Yeah.
This is the single. If you were looking at a single one, this would be the one you'd see, right?
So
Most
what
of the
you're
time.
saying is, just looking at this, you know it's not for an aircraft.
Actually, I would probably need it in my hand because this picture doesn't tell me how big it is.
I can tell.
Yeah, you can tell.
Because the aircraft electrodes never extend over the center electrode.
Why is that?
I don't know. All the aircraft plugs I've seen, they never extend out. They always come up next to the electrode. Automotive always goes over the top.
so you do have some that look like that in aviation, right?
Yeah, I'm going to show you the next slide.
Okay.
Oh my goodness. I was extending. Extends over.
So this is an aviation single-sided electrode. Like I said,
It's like a lawnmower plug.
like me, I can't tell
It
you
probably is.
visually looking at this unless I have them in my hand because this one's going to be a lot bigger most of the time than a
It seems like the
aviation one.
part that I don't know what it's called, the part that goes over the center electrode, but it seems like it's more rounded than the one for.
It's a lot
automotive.
shorter.
What
Much
what
colder
engine
plug.
was you find this on? Any idea?
I don't know. I can look it up.
It's a lawnmower.
It's a lawnmower.
Line.
So I'm going to tell you one thing. This one is a brand new plug. The one I just showed you is not a brand new plug, for one. Just to let you know. But they're just showing the difference because I know like I said, the way I can really tell, and he probably can tell more because he's looked at so many automotive spark plugs. But the only way I really can tell based off the pictures is if you put them in my hand. I'll be able to look at it. And most of the time, spark plugs will have writing on the side and tell me what they are.
So you're saying they're typically bigger in airplanes?
Typically, yes. Not all the time, no. But some of the ones I've seen, and then if you look at that, I think that Champion is rated for both. It has both the holes for an automotive spark plug and an aviation one. And if you notice, the aviation one is bigger. I'm not going to say that's all the time, but generally, yes.
Do aviation plugs ever have exposed porcelain on the top? Or exposed insulator?
Exposed insulator.
Yeah.
Is that what that is? Exposed
This
insulator?
is
At the- No, down at the bottom.
down at the bottom. No. What do you mean,
So-
like this?
That's the
Oh, yeah.
porcelain.
Oh, yeah.
Do they have exposed that?
Oh yeah.
Okay.
We're gonna go through probably not in this class period, but next class period I'm gonna show you how different ones are put on, and you might see those on older antique
Okay.
aircrafts. But yeah, you'll definitely see those. Okay, so here's the aviation one. So here's an extended core nose. Just like I told you, there's lots of different ones out there. This one is rated for a hotter engine. Just because I can tell by the reach. We're going to go through the reach on the plugs.
So this is a cold plug.
Huh?
Would this be a cold plug?
Cold plug,
It's colder.
colder, yes.
What does that mean? A cold?
We're going to get to that. So just looking at this, I don't know if you guys can see, but can you guys see the cracking going on here? Can't see in the picture? Might be the shadow of the light in here. On my screen I can see, but there's a crack right here. And that's why we happen to have that plug here, is because it was rejected because it has that crack right there. But your guys' picture doesn't show it as clearly as mine. So here's a 2-prong tangent to center platinum spark plug. So if you notice, these guys are a lot thinner. This spark plug is still made out of steel, except it's got these two parts spot welded on there. And the center electrode is also platinum. But the rest of it is still steel. And I was asked which ones are better. That really they all do the same thing. Some people argue with you that these don't wear out as quickly because of the metal you're using. But I've seen these fail just as much as.
The two prongs are made out of platinum.
Yeah,
Yes.
solid platinum or is it plated?
It's solid platinum.
Okay, I was
I don't
wondering.
know.
So if
I
I
need to
took
go-
one of those
it's-
out,
Is
you
that
know,
real gold or is that plated? Yeah, it's real. So this spark plug right here is about $80.
Yeah.
The two massive prong one, our massive one I saw is what runs between 26 and
26 and
30 or something.
39.
So
Yeah.
are those ones are in the cars or planes?
Plates.
Planes.
I don't know. They could be in cars. Are they in cars? I don't know.
Cars can take platinum.
Which
My
planes?
car takes iridium.
And some of my other instructors say that this isn't a car class, but a lot of people can relate to cars. So if somebody has some car information, I'm all for it.
One time they call us fine wire plugs. So you said, oh yeah, I run fine wire plugs in my airplane.
Yeah.
Then that's what you know what I'm talking about.
Everybody see that? Okay. So here's an iridium one. Oh, here's the one you can see it better, right? You guys can see these right here, cracks, right?
Yep.
Okay, that's no bueno. So this is iridium single fine wire one. So when you hear fine wire, this is what they're usually talking about. Same deal as the platinum. It is spot welded on here. And it's iridium, and so is the center electrode.
How much is that worth?
That one I think is in between them. I'm not 100% sure. But
Oh,
the
it's
platinum,
60 or 70 bucks.
60 or 70. Yeah, the platinum's the most expensive, and the massive ones that are just made out of steel are probably the cheapest ones you'll find, just because of the material.
How come they never use gold?
$2.
Doesn't survive.
Gold doesn't grow.
Hmm?
It doesn't corrode, but there's a
Well,
lot
it doesn't
of other
corrode, but it
things
can't
that
take the combustion.
So the corrosion factor, yeah, it's great, but the other factors not so much. Okay, does everybody see that? So these are a couple different kinds of spark plugs you'll see out there. All right, so just like I promised, we're gonna go through the designation. Tempest has its own model designation as well, but we're gonna go through Champions. Champions is most likely what you're gonna see. But Tempest is almost identical, except they add a U at the beginning, I believe, just so you know it is a Tempest plug.
UREN and URHN.
So you'll know if it has a U in the front that it's probably a Tempest plug. And that's pretty much the only difference. Got it down? Everybody that wanted it got it down? We're going to go through each line. So, number one, which is the R, basically tells you there's a resistor in there. So that's what that R stands for at the beginning. So barrel style is, so you got unshielded, you've got shielded at 5/8, H is 3/4, and I believe the one I showed you guys was an H, right? So you're gonna know the shielded is at 3/4, 20 threads. So it's a pretty thick threads versus the other one. And you might see a V, which is metric.
What is the M1 8X1?
The number. It's just a designation. It just means metric on the other side. So right here. It's just the number. Nothing really. Just the number they put in there.
18 millimeter.
Oh yeah, well that's yeah. But usually it says 18 millimeter here. What does the by one mean?
It's the pitch. So they can be 1 or 1.25 or 1.5 is there.
There you go.
Just like the other ones are 20 threads, 24 threads.
Something like threads per millimeter or something.
It's
Threads
pitch.
per
It's the
millimeter.
pitch. It's actually it's 1.1 millimeter pitch.
Is that per thread? Is that what you're telling us?
Yeah.
That's what he's asking. That's what he's asking you. And so I'm asking you.
Threads per millimeter, I think.
Threads per millimeter.
I'm not gonna lie, I don't know. I don't know.
It's 1 millimeter is the pitch. From one top of one peak to the next is 1 millimeter.
So it's the thread. That's what you're basically saying then, right?
Thread pitch, yeah,
Yeah.
It's like 20 threads.
Okay, so yeah, it's basically what he's saying. Just like
No.
with Brian.
No, it's not what he's saying.
What is he saying?
He's saying threads per millimeter. He's saying the thread spacing is 1 millimeter.
Okay.
Do you see the difference?
Yes.
Yeah,
So
that's
between-
why, because
So
If it
between
was-
each thread, you're telling me it's one.
The peak on one to the peak the other.
Yeah,
Yeah,
so
valley one,
between
valley
each
other,
thread.
1 millimeter.
yeah, you see how different that. Yeah.
There you go.
Oh, wait, I'm not gonna write that down.
Not gonna write that down.
Are we gonna be required
You're gonna
know
just
this?
have to YouTube that one.
I'm not gonna give you a spark plug on your test and tell me, hey, what does each one of these mean? I might ask you what does reach mean, but we're gonna have a basic definition of what reach is. But no, I'm not gonna have you memorize. This is just showing you what each number means. Because you guys, when you're looking up these, when you go to your engine, I'm gonna have a couple people. Somebody's told me that you can go to the internet. So in the next slide, 2 slides, I'm gonna have 2 different people look up each one of these, and you're gonna tell me what exact spark plug goes in there, and tell me what each one of those numbers mean. Because these are things that you're gonna do when you're out in the field.
What's it used to have more than?
The U, for what? This one?
Yeah.
That's the model. That's just the model number.
That's just the model number.
So like it could be an A, a B, a C.
Okay.
It means magic.
Magic.
It's all magic.
Nice.
You don't have to write it all down, Drew.
I'm not. Okay.
You guys let me know when you're good and we'll go to the next slide. But no, I'm not gonna make you memorize this. You can look it up in the book. But we are gonna go through reach. And this 13/16 right here, that actually is the length of the actual threads. So from here to here, that's what it's talking about on this particular application. Does everybody understand that? I'm going to show you what reach means, but that's what it's talking about. So when you see these numbers, when you see the picture again, it'll tell you what the reach is, and it is the distance from the whole threads. Not in between the threads or anything like that. It's actually the whole threads. Does everybody have that wanted it? Got it? Okay. All right, so the number 4 number. Number of the hours was 40. So usually you'll have a low number, high number, a cold, a hot. Usually it'll be between 26 and 50. The one we happen to have is 40. And then just like I told you, the design, these will tell you which one you had. So you'll know exactly that you have 2 electric massive, 4, and so forth.
Is that the range, 26 to 50?
26 to 50, that's usually the range that spark plugs run in. But the spark plug that you have is like number 40. That's its designation in that
So
line.
it's on the hotter side, but that is the range. 26
Yeah.
to 50.
Yeah, so the hotter side would probably be not a faster running engine. Usually you're going to have a colder spark plug and an engine that runs at higher altitudes that's a faster engine.
What does 26 mean?
We'll explain that as I go on to reach, and it's basically how much it dissipates the heat into the cylinder if the spark plug's running hotter or colder. So that's basically that's just a number they use for if the spark plug's running colder or hotter. So usually if you're in a smaller aircraft and smaller engine, you're probably going to be running a hotter spark plug. Like I said, you guys don't have to memorize any of this. Just kind of get a feel of what each one means. So when you're looking at a spark plug and you see the numbers and you're like, oh, I have an E, so I'm going to have a 2 electrode massive. So you know exactly what the spark plug's going to look like. You got that?
Yes.
I still got a couple guys writing. So the next slide, I'm going to have a couple of you guys. So whoever's got their internet up, Lisa, do you want to look up a TIO 540U? It's type certificate data sheet, and see if you can find what the spark plug is for that. Now it's going to be a Lycoming. So Lycoming engine.
Champion.
You're a champion?
No, spark plug for champion.
You can't put a Tempest in there?
I didn't look at the temp certificate. I think the manual.
Oh, you can help her find it.
Sure.
I encourage you guys to work as partners. And then when Jude is done, can you look up a Continental 0470U for me and tell me what the spark plug is off of that? I'm only going to go to the next slide and I'm going to wait for you. I have plenty of time to wait for you. So everybody who wanted that got that down? So we're going to wait for them and I'm going to go through reach and heating rating and then we will break for dinner. There's only about 5 or 6 slides left. I want to see if you guys can look this up and tell me what they are. And if anybody else has a computer and wants to help them out to look that up, I encourage it. data sheet?
I'm working on
Page one. Page
Oh, the internet here? I don't know how fast the internet works here. It's relatively slow here.
It's not that fast.
It's hit or miss.
And I use the internet here. Lonnie's computer doesn't. It
It's
takes me
a
an hour and a half.
REM 37BY.
So for the Continental, it's
REM 37BY.
say that one more time. REM
37BY.
UY
B
BY.
as in boy. Y as in we don't know why.
I don't know what the Y stands for.
We know what the Y stands
So
for. Y stands for the projected core noise.
there you go. So the R is, we know it's got a resistor in there, right? And then you can look up the E, whatever the E is in your notes. What's the E?
E is
Extended reach.
shielded,
Stands for what?
Extended reach, I don't know.
shielded 38 by 24 thread.
Okay. And then what's the M?
18 millimeter reach, half-inch thread,
yeah.
or three,
Oh, here it
18 millimeter mounting thread, half-inch reach, and 7/8 backside,
is. And then we know that this is for the heat ranger.
37.
So you guys got the other one? What's the other one? I thought you said you guys got it.
I don't know.
I thought he got it. Why don't one of you guys make it even easier for you? Look up the service instruction for Lycoming 1042 AE. But see how quickly that was pretty easy to look up, right, Jude?
Yeah.
Yeah, roughly.
Yeah.
So if you guys want to do that, practice looking those up because that's going to be something that you're going to do out in the field. You're going to look these up. And like I said, you can't interchange these. You have to put the spark plug in there that it's rated for.
What service instruction?
The service instruction, service instruction is going to be 1042 AE. Lycoming.
So on the BY, so that's both twin electrode nickel and it also has a projected core.
Is that a 540U? Yeah. It's a 540U.
Yeah, TIO 540U. The type certificate data sheet will actually tell you to reference the Lycoming service instruction 1042 AE.
It's a champion. It's another champion.
You also can look through Champion for champions for their spark plug for that. But
Avalon should have it.
yes, but I recommend going through the type certificate data sheet first.
This there's a champion spark plug application chart which has all the champions and the.
But what if I want to put a Tempest in there?
Huh?
What if I want to put a Tempest in there? Can I?
Well, I'm just saying you should go by the recommended.
Well, Champion is what is that manufacturer? You could put a Tempest on there.
Yeah, they improved.
Yeah. You guys find it? I thought the Continental would be harder to find. Well, I'll have them keep looking. But you can see that it's pretty easy. Like I said, if other of you guys want to take a look and pick an engine and look up the spark plugs, I recommend doing that. Just so you guys get familiar with type certificate data sheets. If you haven't taken Recips 1 already, you'll be looking at that type certificate data sheet. So the more you get familiar with those, the better.
That one right there. So you can see the champion.
What's the champion number?
RHB 37E.
RE what?
RHB
Oh, RHB
37E. And
3.
you can also use RHB 32E. And then you can also use Tempest.
I'll just do 3-2.
Okay. So
But you
don't-
guys see that you can find these numbers, and so now you guys know what R stands for, what the H stands for. If you have the chart, you don't need to memorize it. You can look it up, and it'll tell you what each of them stand for. I'm not going to make you memorize them. I'm not going to come up to you and tell you what does RHE 37B stand for. But now you guys know where to find it.
And this
Okay.
chart is interesting.
temperature chart is interesting. So I encourage you guys to look that stuff up. Okay? Alright, so we're going to go through our last 5 or 6 slides. We may go to lunch a little bit later, but then I will still extend it for the 30 minutes into lab. Okay? So, reach and heating rating. So, here's the reach. And it's from the gasket to the end, because you're going to count that gasket in there.
And what's the gasket look like? Okay.
This is what the gasket looks like. It also helps with heat transfer. The reason why they're made of copper is because they will crush, and copper is a good source of heat transfer. But each cylinder is going to have a different reach on it. So when we were looking at that chart and it said the reach is, we have 18 millimeter and the reach is 13/16, this is what we're talking about. It does. When it means it includes the gasket, the gasket's included in this range, or on this side. So after the gasket, you're going to measure the thread pitch afterwards. That's what that means. It's seems kind of backwards, I know, but that's what it's meaning. It's meaning after the gasket. So the gasket's included in the length of that spark plug. Because you're not going to install one of these without a gasket. Or you're just asking for trouble. Does everybody have that written down? Okay. Differing lengths allow for thickness of the cylinder head, proper immersion depth into the combustion chamber. This word right here, I want you guys to remember it. It's an important word. You'll see it a few times. Means how far it goes into, pretty much. So I'm going to control the spark plug temperature heat range. Does everybody have that written down?
Nope. Okay.
Good?
Yep.
Okay. So, here's a picture of a short reach versus a long reach. Most likely, in high horsepower engines, you're going to have a longer reach spark plug. The reason why is because the cylinder wall is thicker. Basically, it's for structure necessity. So when you look in these, you don't want to screw this one into here. Why wouldn't I want to do that?
Piston is in it.
Piston hitting it is a big one. I don't want the piston to hit that, right?
Yeah.
That might be another reason.
Would it interfere with the gap timing, or not the gap timing, the
When
timing.
it sparks and where
Yeah.
it sparks at. Yes. Another one. So there's reasons why these are rated for certain ones. So you can't put. So if you put this short one in here, what do you think's gonna happen?
Full fire.
Might not fire.
Or delayed fire.
Might work fine.
Well, let's go try it. Marty, let's go find your airplane and we'll go try it on the ice.
Yeah, you can pass.
No. So there's a reason for that, and basically the reason why the higher horsepower has a longer reach is for structure because you're gonna have a thicker cylinder wall. Okay. So everybody see that? Everybody kind of understand what reach is? Okay. Let's see how far I can go here. Okay. Okay, so the temperature range is adjusted by designing more or less inside the contact area with the shell. I'll wait till you write this down. We're almost done. We got a couple more slides. So the more ceramic contact with the shell produces a colder plug. Why do you think that is?
Conducts more heat.
It conducts less heat because it's going to push, it has more surface area for the heat to come out of it. So these spark plugs actually disperse heat out of the plug into the cylinder head. There's actually a cutout I take further down. So if we had a shorter one in there, has less ceramic area, it's not going to transfer the heat as fast to the cylinder head. So that spark plug is going to get hotter. So if we're in a high horsepower engine and our spark plug is running too hot, what's going to happen? That thing's glowing in there.
Pre-ignition.
Pre-ignition, and it's probably, what is the ceramic? What do you think's going to happen to that ceramic in there?
Correct.
Melt, crack, and if it cracks, where is that going? Where are those pieces going?
Into the gap. Yeah.
Into the engine, right?
Engine,
Into the
cylinder.
cylinder. And if we have that, we just put FOD in there. All sorts of bad stuff's going to happen.
We'll show them the oil analysis.
Huh?
So you'll catch it on the oil analysis.
Oh, yeah. As long as you can't read part numbers in the oil filter, you're good.
It'll help the ring see better.
Help the ring seat better. So everything in here is to help transfer heat. So if we have a shorter plug in there, it's probably going to be a hotter running plug. For that reason is there's not so much ceramic area. Does everybody understand that?
Sure. No, yeah, seriously.
I don't understand that last sentence though.
Yeah.
Longer, shorter, center.
So the longer the shorter the center electrode, it's the insulator length. So the longer or shorter this is going to determine the length of the ceramic area.
Oh, okay.
We could probably
It should be-
reword that.
Would
Probably,
you like me to reword that? I will tell Lonnie you need to reword that.
you could just delete it altogether. It makes no difference.
Yeah.
You guys are lucky I'm not showing you North slides. We'd all be going. He uses words like that all the time.
can we say like insulator length varies depending on the length of the electrode?
Sure. You can write that in there.
Made more sense.
There's words that make more sense to me than the words they use, but some of the words you gotta learn use. So does everybody understand that? Pretty simple? Yeah? Okay. So here's a picture, a cutout of a colder type versus a hotter type. So where the ceramic area is, it actually has more areas to disperse that heat out into the cylinder head versus the hotter type ones.
So it's thicker for the hotter ones. Is that what you're saying?
No, it's gonna be longer.
Oh, longer. Right.
The cylinder head's gonna be thicker, and that's what gives you the longer reach spark plug. So this would be longer or shorter depending on the horsepower.
But the contact area is what's distributing the heat, right? That's what you're saying.
Yeah, the ceramic area. So the longer this whole contact area is going to be dispersing outward. So if the spark plug's shorter, it's not being able to disperse out as much heat. It's not contacting the cylinder head as much. So if I have longer threads in there, it's obviously touching more of the
More surface.
surface area. And like I said, if we, not only for firing purposes, but if we had a smaller spark plug in there, it's going to run much, much hotter, and we risk the chance of breaking down, the ceramic breaking, all sorts of things breaking down in there if it's running too hot. This helps make the spark plug at the same temperature, roughly the same temperature as the cylinder. Roughly. Not going to say exactly, but roughly. And that's important. Does everybody kind of understand that? I look so excited.
I'm excited.
You're excited?
I am.
That's good. Okay, spark plug temperatures need to range from 800 degrees Fahrenheit to 1630 to operate correctly. Too hot causes preignition. Too low causes lead fouling and engine oil fouling. So if we're running too not hot enough, most likely we're not burning all of that fuel, right? Just got that written down. That's alright, it's still gonna be there. So, like we're talking about the cracked insulator, if it's cracked, what's gonna happen to the spark? Just troubleshooting things. So
Grounded stuff.
it's gonna ground itself through that crack, right? It's gonna want to go the path of least resistance. What if the gap is too close on the electrodes?
Like,
What's gonna
Too-
happen?
much
So if the
shorter.
gap's too small,
Quite short.
Too cold.
it's not going.
Too cold, yeah, because it's not handing out very long. It might be colder.
colder. Do you guys agree? I'm looking at you, Brian.
You'll have a weak spark
Okay.
because it doesn't take as much voltage to jump a smaller gap as it does to jump the correct size gap.
So it's not gonna
It's,
ignite the way it should.
for sake of conversation, if it takes 10,000 volts to jump the correct gap, if you make the gap smaller, it may only take 5,000 or 6,000 volts to jump the gap. That may not be sufficient to light the fuel air charge.
What else would that cause if it didn't need all those volts?
I'm sorry?
What else would it cause?
Passive.
Passive reactants. Cause more of that.
Genius.
He's genius. He's using the words that are on the board.
I don't know what it means, but.
We still don't know what it means.
I'm kidding. Bounce back.
Please do not kid me. You guys ask so many questions. I at least want you guys, if you know something, please don't joke with me. You already pushed me to the limit. So if you know something, don't mess with me. So I want you guys to think about these things when you guys are doing your project in the lab, because these are things you're going to look for out in the field. Okay? So you guys can go to dinner